Hey math enthusiast, I'm here to continue with section 9.7 dealing with dilations. For this first example, we're trying to determine where the center of dilation is going to be located if it's not at the origin. So they give us our pre-image down here, DOG in black, and then our image, D prime, G prime, and O prime in red. So I'm trying to figure out where did it grow from. All right, clearly the center of dilation is not the origin. I'm going to say the center of dilation is more down in this location somewhere, because obviously it's growing out from this point. So what I want to do is I want to connect the pre-image points with the image points. Now, when I connect them, it's not just going to be a segment from G to G prime, but it's going to continue going outside of those two, so a whole line. I'm going to do the same thing from O to O prime and D to D prime. And what I'm looking for is where are these three going to intersect. All right, it's a little bit easier if you have a ruler and some paper. But essentially it should come out looking like this. So now I can locate my center right here, which appears to be at -5, -2. And the next thing they're asking for is the scale factor. All right, so did it get smaller? Did it get larger? All right, remember this is my pre-image, DOG. So in this case, I'm definitely going to say that it's an enlargement. It's definitely getting bigger, so that tells me that K is going to be greater than 1. So now I want to see if I can figure that out. One way to do it is to compare how far the center is from your points. So how far is it from the center to G, and how far is it from the center to G prime? Well, unfortunately, we're dealing with diagonals there. So it might be easier if I just compare these vertical sides, because I can easily see that DO is 2 units, and that D prime O prime is actually 6 units. All right, so if you remember, what I'm going to do to figure out my scale factor is I'm going to compare the length of the image, so D prime O prime, compared to DO. So in this case, it would be 6 to 2, which is going to give me a scale factor of 3 or 3 to 1. So for the second example, I have my image inside of my pre-image. So notice this is A prime, B prime, C prime, and D prime inside of A, B, C, D. That tells me that my center of dilation is going to be somewhere inside of that image. So once again, I'm going to do what I did for the last problem, and I'm going to connect my points, okay, my pre-image points to my image points. So we're going to go A to A prime. I'm going to try to draw a straight line through them. I want to go B to B prime, a straight line through them. C to C prime, that one's going to go straight up. And I can kind of already see where they're going to intersect. D to D prime. It looks like they are going to come together right here. Now, this is super messy, so I'm going to erase some of this. And what I can really do is just focus on B and B prime and C and C prime. Wherever they intersect, the other two are definitely going to intersect. So there's my center of dilation. So it's not the origin in this case, it is at 4, 2. Now in this case, it looks like the image is smaller, so it looks like it's going to be a reduction, which tells me that K is going to be somewhere in between 0 and 1. So once again, what you could do is you can compare some side lengths. So for example, I could compare maybe AD to A prime D prime, if you want to do that. All right. Or what you can do is compare how far is it from the center to my image compared to the center to my pre-image. Now in that case, it might work a little bit easier because those are just vertical or horizontal lines if you're dealing with B and B prime here. So remember, this was my center. And the distance from the center to B prime is just going to be 1. And if I want to figure out my scale factor, I'm going to compare the center to B. How far is that? So in this case, that's 2 units. So there's my scale factor. All right. It's definitely getting smaller. My scale factor is in between 0 and 1. In this case, it is 1 to 2, or a scale factor of a half. So I know that A prime, B prime, C prime, and D prime is actually half the size of the original figure, the pre-image. Now for number 3, they haven't graphed anything for me, so I'm going to start off and I'm going to plot A prime, B, and B prime. Now that I have my segments graphed, next I want to locate where the center of dilation is coming from. Okay, so remember A and B, that's your pre-image, and then A prime, B prime is your image. Definitely looks like a reduction at this point. It's definitely getting smaller, and I'm going to say that the center of dilation is down here somewhere. It's definitely shrinking down to that point. So I'm going to do what I did last time. I'm going to connect my points, B to B prime. I'm going to try to continue drawing this as straight as I can. And A to A prime, continue drawing that as straight as I can. And that should locate where my center is. I have some straighter lines here to help me out. It looks like it's going to be right here on the x-axis at, we have 6, 0. And the next thing I want to figure out is the scale factor. Now, in order to find that, what I'm going to have to do is I'm going to have to figure out the length of AB, and I'm going to have to compare it to the length of A prime, B prime. So, in order to figure this out, what I can use, since I have the coordinates right up above, is the distance formula. So what I'm going to do is x2 minus x1 squared plus y2, which is 6, minus y1, which is 2, squared. And then I just want to simplify that to figure out what exactly is AB. How long is it? So we have 6 squared. I have 4 squared, which is going to lead me to 36 and 16, which leads me to the square root of 52. Now, I could also simplify this further. It would be square root of 4 times square root of 13. That would give me square root of 52, which is going to turn into 2 square root of 13 for my final answer there. Now, what I want to do is compare that to the length of A prime, B prime. So I'm going to use the distance formula again, just for those image points instead. So it's going to be 8 minus 5 squared plus 3 minus 1 squared. Simplify what's in our parentheses. We end up with 3 squared plus 2 squared, which is going to give us, we have 9 plus 4, which gives us square root of 13. So now that I have my actual length, so we have 2 radical 13 and just radical 13. So what I'm going to do to figure out my scale factor, remember, is I'm going to compare my image, A prime, B prime, to my pre-image, AB. So it looks like in this case I end up with square root of 13 over 2 square root of 13. Well, I can get rid of those square root of 13s, and it's just going to end up being 1 to 2. So once again, I have a scale factor of a half, and that does look to be the case. A prime, B prime does look to be about half of AB. Now, number 4 here is a little different. I want to perform a dilation, but in this case, the center is not going to be at the origin. Instead, it's going to be at -2, +1. Now, I want to dilate it by a scale factor of 2. Now, what I would have done before is just multiply my x by 2 and multiply my y by 2. But the problem is that's not going to work if it's not centered at the origin. So first thing I did was just jot down my coordinates. Now, in order to dilate this with this center at -2, 1, first thing I'm going to want to do is move that center to the origin. So it's going to be a very similar process to what we did when we did rotations that were not around the origin. So first thing I want to do is translate it. And my rule is going to be x plus 2, because I want to go 2 units to the right, and y minus 1, because I want to go 1 unit down. So now I want to come up with my first set of new points. Now I have A, B, and C after the translation. A prime, B prime, and C prime. Next thing I want to do then is dilate it. So in order to dilate it, what I'm going to do is I'm going to multiply my x coordinates by 2, and I'm going to multiply my y coordinates by 2. So now I've come up with my double primes. So now the figure has been dilated, but it's been dilated with the center as the origin. So what I want to do now is I want to move everything back to where it came from. So I want to do the exact opposite translation that I did earlier. So I am going to translate it again, but instead of adding 2 to my x's, I'm going to subtract 2. And instead of subtracting 1 from my y's, I'm going to add 1. So it's the complete opposite of that rule I did earlier, which gives me my triple prime points. Last thing I can do is just graph them to just get an idea of what this is going to look like. So my final image, A triple prime, B triple prime, C triple prime, definitely larger than my original figure. All right, and it's definitely moving away from that center of dilation that I marked at -2, 1. So before I move on, I want to think about coming up with a faster method. Is there an easier way for me to get from my pre-image points, A, B, C, to my final A triple prime, B triple prime, C triple prime? So let's go back to the beginning of the problem. So what I want to think about is, can I go through all those steps using just one rule? So let's say I'm starting off with my basic point, xy. After that, I'm going to want to translate it. Okay, so what I'm going to do is I'm going to take my x, I'm going to add 2. I'm going to take my y, I'm going to subtract 1. Okay, so now I have my rule, x plus 2, y minus 1. Next thing I want to do is I want to dilate. So in order to dilate, I'm going to multiply my x coordinates by 2. I'm going to multiply my y coordinates by 2. So what I'm going to do is I'm going to multiply each of these binomials by 2. So that means I'm going to end up with 2 times x plus 2 and 2 times y minus 1. I want to simplify that real quick just by distributing that 2, which is going to give me 2x plus 4 and 2y minus 2. Running out of space. So now this is my rule, 2x plus 4 and 2y minus 2. The last thing I want to do, if you remember, was I translated it back. So I translated back, and in order for it to get back, I did x minus 2 and y plus 1. So unfortunately, I'm going to have to erase my final answers because I ran out of space. I've moved them off to the side over here, and now I'm just going to come up with my final rule. So I'm going to take my x coordinate and I'm going to subtract 2. So remember that this whole first term is your x coordinate. So now it's going to turn into 2x plus 4 minus 2. And then my y coordinate here, which is 2y minus 2, and I'm going to add 1. Last thing I want to do is just simplify my rule and get rid of these extra parentheses. So I'm going to end up with 2x plus 2 and 2y minus 1. So let's clean this up and see if I can apply this one specific rule to my original points. So what I can do now is I can take my original x and y and I can plug them into this rule that I have down here. So in order to figure out where a prime is, in this case technically it would just be a prime because there's really only one move, what I would do is I would take 2 multiplied by the x in a plus 2, and then 2 times y. Well, my y from a is 5, and then minus 1. After I simplify that, it looks like a prime is going to end up at 6, 9. And that's what I have right here. So I could use this rule for my other points to figure out where their location is going to be. So then for b prime, for example, it would be 2 times the x value plus 2. And then for my y, it'd be 2 times y. In this case, our y is only 1 minus 1. So now it looks like b prime is going to end up at 6, 1. And then I could use the rule again to figure out my final point C. And I'm going to end up with 12, 1. Just a little side note, look how good this A is. Doesn't that look like a perfect A? I'm very proud of that. All right, moving on. Number 5 is very similar. So once again, I want to dilate. My center is not at the origin. It is at 8, 6, and the scale factor is 1/2. Right away, I know it's going to be a reduction. It's going to be getting smaller. My center is inside my pre-image, which tells me that my image is going to be somewhere inside of my triangle, my pre-image, SRT. What I want to try to do, instead of going through each step, I want to try to come up with my rule. So if I'm starting off with any xy point, how can I dilate it if it has a center of 8, 6? Okay, first thing I would have to do is translate that point. And I need to get it back to the origin. So that means I have to go the complete opposite of the coordinates they give me. So I'm going 8 units to the left, and I'm going 6 units down. Next thing I have to do is dilate it. So I want to dilate it by a scale factor of 1/2. So now my point is going to become 1/2 times my x coordinate, x minus 8, and 1/2 times my y coordinate, y minus 6. Okay, let's distribute this, get rid of the parentheses. It looks like I'm going to end up with 1/2 x minus 4 and 1/2 y minus 3. Last thing I want to do is translate it. Now I want to go back to where I came from. So now I'm doing the opposite of what I did initially. So I'm essentially applying the coordinates of the point that they gave me. So it's going to be x plus 8 and y plus 6. So now what I'm going to do is I'm going to take this x value and I'm going to add 8 to the end of it. So I'm going to use some parentheses to start to make it a little bit easier. So I have 1/2 x minus 4, close my parentheses, I'm adding 8 to that. And then I have 1/2 y minus 3, and I am adding 6 to that. Finally, I'm just going to get rid of my parentheses and I'm going to combine these like terms. So it looks like my final rule in this case, I'm just going to label it as R, is going to be 1/2 x plus 4 and 1/2 y plus 3. Now what I want to do is go back to the beginning and use this rule to find my new coordinates S prime, R prime, and T prime. So I have my original coordinates, S, R, and T, and let's focus on finding S prime first. So I'm going to rewrite my rule, 1/2 x, but instead of x, I'm going to fill in 8 right there, plus 4. And then we have 1/2 y, and then my y coordinate is also 8, plus 3. So lastly, to figure out where S prime is, I'm just going to simplify that. Looks like we're going to end up with 4 plus 4, which is going to give me 8, and 4 plus 3, which is going to give me 7. So S prime is moving down. It's moving 1 unit closer to my center of dilation. So for R prime, now when I plug that into the rule, my x coordinate for R prime is 2. Plus 4, and then we have 1/2 y, well our y coordinate is also 2, and then plus 3. So it looks like once I simplify this one, I'm going to end up with 5 and 4. So if I plot that, same idea, it is getting closer to my center of dilation right here. Last point I need to figure out is T prime. So it's going to be 1/2 x. For T, my x coordinate is 12. And then plus 4. And then we have 1/2 y. In this case, our y coordinate is 6. And lastly, plus 3. So now I can just simplify this. It looks like we end up with 6 plus 4, which gives me 10, and 3 and 3, which gives me 6. So T prime is going to be at 10, 6. So now I can connect my 3 points to figure out where exactly triangle R prime, S prime, T prime is. So it pretty much is where I predicted. I knew it was going to get smaller because of that scale factor, definitely a reduction. The center of dilation is inside my preimage, which means that it's going to shrink towards the middle of that preimage figure. For number 6, they don't give me any graph. I'm dealing with triangle ABC. What I'm trying to do is I'm trying to dilate it with the center at 2, -5. And once again, I want to figure out what is the rule for this transformation. So let's start off with a general point before I worry about A, B, and C. Now, if I want to dilate this by a scale factor of 2, first thing I need to do is get it centered at the origin. So right now the center is at 2, -5. I want to move that point to the origin. In order to get there, I'm going to go 2 units to the left, so -2, and 5 units up, so y plus 5. All right, notice how it's just the opposite of the coordinates they give us. +2 and -5. Then became -2 and +5. After that, I want to dilate. So now I'm applying my scale factor of 2. So it's going to be 2 times my x, which is x minus 2, and 2 times my y plus 5. The reason I can do this now is because once again, it is centered at the origin. So next, I'm just going to simplify it down here. So when I distribute, we're going to get 2x minus 4, and we're going to get 2y plus 10. Lastly, now I want to translate it back to where it came from. So I want to undo what I did initially. So instead of subtracting 2 and adding 5, I'm going to do the complete opposite of that. Now I'm going to use some extra parentheses here. So it's going to be 2x minus 4. And then I'm going to write this in a different color just to show it. I'm adding 2. So once again, I'm doing the exact opposite of the translation I did initially. For my y coordinate, we have 2y plus 10. And then what I'm going to do to my y coordinate is subtract 5. So it's the exact opposite of what I did earlier. Last thing I want to do is just simplify my rule. So my final rule is going to be 2x minus 2 and 2y plus 5. All right, now what you can do is you can actually go back and figure out your coordinates. So for a prime, it's going to be 2 times 0 minus 2 and 2 times 0 plus 5. So it looks like in this case I'm just going to end up with a prime, which is at negative 2, positive 5. Next thing I want to do is b prime. So b prime is going to be at 2 times 2, because that's my x value for b, minus 2, and then 2y, so it's going to be 2 times 5 plus 5. So now we can simplify this one. It looks like I'm going to end up with 4 minus 2, so I'm going to end up with 2. And then we have 10 plus 5, so I end up with 15. And lastly, I slid this over a little bit just so I could fit c prime in here. So for c prime, it's going to be 2 times negative 2, because that's my x value for c, minus 2. And then 2 times 7, because that's my y value for c. And then plus 5 at the end. So now it looks like c prime is going to end up at negative 6, 19. And number 7 is very similar, in which case I want to come up with a rule for dilating with a factor of 2/3 with the center at 6, 4. So once again, I'm just going to start with a random point, x, y. If I want to dilate with the center at 6, 4, first thing I want to do is translate that to the origin. So I'm going to do the complete opposite of those coordinates. I'm going to do x minus 4, or sorry, x minus 6, and y minus 4. Next thing, now that I've moved it to the origin, I'm going to dilate it. So I'm going to multiply my x and y by 2/3. So it's going to be 2/3 times x minus 6, and it's going to be 2/3 times y minus 4. Next thing I want to do is just distribute that just to clean it up a little bit. Looks like we end up with 2/3 x minus 4, and we end up with 2/3 y minus 8/3. Not very clean. Okay. The last thing I want to do for my rule is translate it back. So I'm going to do the exact opposite of what I did earlier. I'm going to write it down below just so I have a little bit more space. I'm going to add an extra parentheses, so I have 2x minus 4, and then I'm going to add 6 instead of subtracting 6. Then I have 2/3 y minus 8/3. And in that case, instead of subtracting 4, I'm going to add 4. Last thing I want to do is just clean all this up so I have one final rule. So I'm going to have 2/3 x plus 2, and then I'm going to have 2/3 y. So right now I have negative 8/3 plus 12/3. Now they have a common denominator. Now I can add them together. So I end up with positive 4/3. Now I have to worry about dilating my original points A, B, and C. So let's clean all this up first. So I have my rule jotted down up at the top. First thing I want to do is apply it to A. Now if you notice, A is actually the center of dilation as well. That means that A should not move. So when I calculate A prime, it should end up at 6, 4. So let's hope that's the case. So I go for 2/3, plug in my x from A, plus 2. 2/3, plug in my y from A, which is 4, plus 4/3. So now let's go through and simplify this. It looks like I'm going to end up with 4 plus 2 for my x. And then over here, it looks like we end up with 8/3 plus 4/3. So I know I'm going to end up with 6 for my x coordinate. For my y coordinate, it looks like it's going to be 12 over 3, which is going to give me 4. All right, so A prime does not move as I predicted because it is the center of dilation. Then I'm going to go on and try it out for B. So for B, we got 2/3 x, which is 3, plus 2. And then for my y, we got 2/3 times 1 plus 4/3. So it looks like I'm going to end up with 2 plus 2, which just gives me 4 for my x coordinate. And then we end up with 2/3 plus 4/3, which is going to give me 6/3, which is 2. So B prime is going to be at 4, 2. And then take a minute and see if you can figure out C prime on your own. And I'll jot it down in a second. And then I end up with C prime at 0, 4.